Hey there everyone and welcome back. Today we're going to be automating the tree cutting process by using a turtle with saplings and bone meal. It's going to chop down the tree, deposit the logs in the chest, and then plant a new sapling and apply bone meal. Once a tree has grown, it will just continue and it'll repeat this process indefinitely or until it runs out of fuel or till the chunk gets unloaded or whatever. Without further ado, let's just dive in. I'm going to declare a variable here. I'm just going to call it wait time, and this is just going to be how often the turtle is going to check if the tree has grown. So it's basically going to check every 3 seconds. We're going to declare a variable, or we're going to declare a function before we actually build it out. The reason why is because later in the program, we're going to run this function inside of another function before it is defined. And if we don't at least make a name, Lua is going to complain, say it doesn't exist. Now we're going to create a little helper function that is simply just going to check that the turtle has the items we want, aka the bone meal and the saplings. I'm just going to call it has, and then the turtle has 16 slots, so I'm going to run a for loop, let it check every slot, and we're pretty much going to do, actually we need to do a variable here for item, and we're going to run get item detail, and this is going to return a table with the item name and all sorts of data. And really what we care about is the item name. So if there is an item and item name matches whatever item we pass into this function, then we are going to select that item, aka it'll be the sapling or the bone meal. Then return true. It auto-corrected a turtle and it did it again. That's annoying. So there we go. Otherwise, if there is no items, I'm going to return false. Next, we're going to create another helpful function. I'm just going to call it isSap. I'm going to pass name through here. And this is just going to check if the item in question is in fact a sapling. And we could hard code it to be a specific type of sapling like oak, but we're just going to make it any kind of sapling. So we're going to return the name, and we're going to specifically look for sapling in the item name that we return. As long as it has sapling in the name, it's a sapling. Now we need a function. I'm just going to call it wait. And this is going to be the part of the program that just simply waits for the tree to grow. It's going to look for logs, not saplings. And once there is logs, it's going to start digging. So I'm going to let it print out, say, waiting for trees. And then we'll do a little while true statement or while true loop. And it's just going to do a if turtle.detect. So if there's something in front of it, then we're going to do a turtle.inspect because we want it to see what's in front of it. So success and data, pretty much just going to check if it is indeed inspecting something and what it is. So if success, aka there is something, and not is sap, the name of the item that it inspected. So in other words, it is not a sapling, then we are going to exit this loop. Otherwise, it's just going to continue sleeping. And we want it inside the loop. So once it does this if statement, we're going to go ahead and let it sleep for the amount of time we determined earlier, aka 3 seconds. Now we need a simpler function such as, or similar to isSap. I'm going to call it isLog. And I'm sure you can guess what this is going to do. This is just going to return the item and look for or check and see if the item in question has the word log in it. Now I think the last helper function here, or no, well, there's a couple more, but another one we're going to make is turn around because we don't want to be typing turtle.turn left or turtle.turn right a bunch of times. So we're just going to do turtle.turn left twice, and essentially it just turns around 180 degrees. Next, I'm going to make a function called try. We're going to pass 4 different values through here. We're going to do inspect, dig, move, and back. Now, first of all, we got to inspect the block. So pass or call, I'm getting my words mixed up. All right, so first we're going to inspect the block. Need to make sure that it does actually see something and what kind of data it collects. Now, if it does detect something in front of it and it is a log of some kind, then we are going to go ahead and dig, move, explore, back. Now, the reason why we're doing it this way is because it's going to be very similar to our mining turtle, where it's going to look for more logs while it keeps digging upwards, so it doesn't miss logs. One caveat to this program is that it's not going to check logs that are diagonal. So if it's not completely adjacent, forward, back, bottom, up, it's not going to see it. And I did attempt to implement this, but I felt that it made the video a bit too advanced for the scope of this series, whereas this is supposed to be a beginner-friendly series. So we'll definitely revisit this in the future. We're going to call a function turn and try. Or pretty much as it's named, we're going to turn, try. So try, we need to pass 4 different arguments here: inspect, dig, move, back. So let's go ahead and do turtle.inspect, turtle.dig, turtle.forward, turtle.back. Now, you see what I'm doing here. It's basically taking this turtle.dig and shortening it to this little dig function that we're making. We're making like little baby functions to handle these other functions, just shortening it down. And then we will do restore. So this one is going to be the explorer that we declared earlier. And now because we declared it earlier, it's going to be a little bit different. Instead of doing function explorer, we're actually going to do explorer equals function. So explorer already exists. So now we're setting it equal to function. And what this is going to do is it's going to handle, it's going to make use of all of these other helper functions we've created and actually recursively start digging out this tree, just like we used in the mining program. So for the in front of it, we're going to do try, turtle.inspect, turtle.dig, turtle.forward, turtle.back. It's similar to what we did here. It's just going to check everything in front of it. Now we need it to turn left. So we're going to do a turn and try, and it's going to be turtle.turn left, turtle.turn right. It's going to check to the left and then face back forward again. So then we will do turn and try again, but for the other direction. It's just going to be the opposite. Now that we've checked the left and the right, we're going to have it go up and then back down. So we're going to go ahead and do try, turtle.inspect down, or my bad, turtle.inspect up, and then dig up, and then have it move up. And then we're going to put a function in here. The reason for this is because we're going to have it check behind it as well. To explain better, this function here is how we're doing the recursive nature of this explore. It's similar to mine. If I go in and bring it up, we have mine vein and explore, and it calls mine vein inside of itself. We're actually doing the same thing, just worded a little differently and more compact. I'm just showing you a different way to go about it. So because we're calling a function inside, we're going to add more to this. We're going to do a turn around, and we're going to try, but behind it this time. So we're going up the tree. We're checking in front, and then to the left, and then to the right. And we are now turning around and checking behind us. Otherwise, it would miss logs that are behind us in case it's a bigger tree. So we're going to run a try and inspect forward and then go back again. So we got our turtle.dig, turtle.forward, and then turtle.back. Then we're going to turn around again because it's done with that. It's facing forward, and then we're doing turtle.up, and then we're going to end. So we ran a little extra function inside of here. Now that at this point, it will have reached the top of the tree. There's no more logs in front or above it anymore. So now we need it to go down, and we're also going to have it go down and check backwards just in case it may have missed something. So it's going to be similar to what we just did, just opposite. So we're going to do turtle.inspect down, turtle.dig down, and then have the turtle move down. And we're going to call a function inside of here again. We're going to have it turn around so that we can look behind it. And then we're going to have it check in front of it and then dig if there are logs. So we're going to inspect and then dig, then forward, and then back. The reason why we go forward in all of these ones is because we want to make sure there's no more logs branching out, because that can definitely happen with the bigger trees. And then we'll have it turn around again to face forward, and then turtle.up. Actually, I just realized that this should actually be down because we want to do the opposite. We're going back down. And then with this, going back up. Okay, and then we will end that off, and then we will end again. Actually, I don't like, no, let's do that. And then that, cool. I don't know, it just looks better to me. So that is the explore function. That is what's going to annihilate the tree efficiently. So I'm going to create a function called chop, and we're going to let it print out chopping tree. We need to do a turtle inspect again. So again, we need a success and data. because we need to see what is in front of us. So if there is something in front of us, and it is indeed a log of some kind, then we will continue. We're just going to do turtle dig, turtle dot forward, and then explore, then turtle dot back. We're going to, this is where we're actually going to be doing our cutting in this function. This explore is handling all of our movement. So together, these two functions are what's destroying the tree. Otherwise, we're going to print no tree to chop, and we'll put in a little sad face because that's pretty sad. So lastly, now that the tree is chopped down, we need to create a function for replanting the tree. So we'll just call it plant. And I'm going to put in a print just because it's helpful to know what it's doing. It's good for debugging, but also for the user. We're going to do a for loop. Got to check that we have a sapling in one of its 16 slots. So for I equals 116. And now we need to get an item for each slot, see what it is. So get item detail. And then, like I said before, this is going to return a table. So if there is an item in that slot, and we're checking for saplings, so we're going to use the isSap function this time. So if it is a sapling of some sort, then we will go ahead and place, or actually first we need to select that slot, and then turtle place, then that will place down the sapling right in front of it. So once the sapling is placed, we can give the turtle bone meal. So let's have it start applying some bone meal, make the tree farm a bit faster. So in this case, we're going to, I guess for this, I'm just going to assume that the bone meal will be kept in slot 2. So we could say the saplings should be in slot 1, bone meal should be in slot 2. So I'm just going to hard code the bone meal to look in slot 2. So if the item count of slot 2 is greater than 0, then we will have it select that slot. And then once it selects that slot, we'll go ahead and run a while loop, because we're going to want it to continuously apply the bone meal until the tree is grown, because it takes more than one, unfortunately. Turtle.place with the bone meal in its hand is essentially right-clicking the sapling with bone meal. And we'll put in a sleep so it's not doing it ridiculously fast. Now we need to check if there is now logs. So we need to do a turtle.detect again. And if there is something in front of it, we'll do the same thing as before, success data turtle.inspect. Make sure that there is indeed something in front of it and is not a sapling. We need to make that an if. If success not is sap, then we will break out of this loop. And that's the end of that. Yeah, that's the end of that. Otherwise, if it runs out of bone meal, let's check that item slot. So if we get the item count of slot 2 again, that equals 0, then we're going to print out of bone meal and then break, because we don't want it to just sit there and do nothing. We might as well just let it sit there and wait for the tree to grow. So we'll end off everything, end the while loop, end that if statement. We need to return something though at some point, and it's probably going to need to be, let's say after it's done applying the bone meal. So we'll do it right here. We're just going to put in a return. And then if we get to the very end of this and we have no saplings in our inventory, then we'll go ahead and print no sapling found to replant. Then it really can't do anything. So lastly, there's only one more function we need to make, and we need to make a way for the turtle to dump everything into a chest, all of the logs and whatever junk the trees may drop. So we're going to print it out, depositing items into chest. And then we need to do we needed it to turn around. I'm going to assume the chest is directly behind it. For this, you can change depending on which direction the chest is. Now, slots 1 and 2 is going to be our bone meal and our saplings. So we only need to check slots 3 through 16. So for I equals 3, 16 do. We just need to select each slot and then turtle.drop, which if you're in front of a storage, it's going to just place it in the storage. And then afterwards, we're just going to let it select slot 1 again and then turn back around. So that'll dump everything in the chest and it'll reselect its saplings and then continue. So those are all the functions. We need to create our main loop for the whole program to run in. And it's going to be nice and simple since we took the time to make all of these help for functions. Our main loop is just going to be a while loop. And we're going to do wait, chop, dump, plant, and then we'll let them know that the cycle has been complete. Waiting for next tree. And this should be pretty instantaneous if we have saplings. Otherwise, or not saplings, if we have bone meal. Otherwise, it'll be at this message for a while until the tree grows. So it should work either way. And that's actually the end of the program. All right, so let's give it a shot. I'm going to go ahead and run it. I ran into some bugs and had to fix them, and we'll see if they work. It is going up, checking around for more logs. When it gets to the top, it's going to turn around, check all around it. When it goes back down, make sure it didn't miss any logs. Could it be more efficient? Sure, but as long as it works. Now it's depositing, placed the sapling, and it is applying the bone meal, and it's going to go again. And it should just keep on going until something causes it to stop. So I ran into some bugs when I tried this. There was some typos. Let's see. There was something in try, or no, was it try? It was turn and try. Something got messed up. This was, for some reason, return, needed to be restore. So I changed that. I was missing the parentheses here, so I added the parentheses. And I believe I was actually in the wait. For some reason, this line got all jacked up. So I rewrote it. Should be this here, if success and data equals turtle.inspect. Got to check that it is not a sapling. Then it breaks out of the loop. So those are the only changes I made. But anyway, this is an automated tree cutting turtle. I mean, it works pretty well, I'd say. You just got to supply it with saplings and bone meal. Of course, it could be improved by having it collect the saplings that it drops, by having it refuel itself using the logs, maybe like have a furnace next to it. And the hardest part, having it check diagonally for the big trees. Because I noticed in my testing that there would be trees with diagonal branches, such as the acacia. It would miss some of these, and that's kind of a problem. So that is a limitation and is actually surprisingly challenging to implement. So if you really want to give yourself a challenge, then give it a shot. Otherwise, like I said before in the video, we'll revisit this and make it more advanced when I eventually start the advanced ComputerCraft Lua series. Hope you enjoyed, and I'll see you guys next time. Bye-bye.